here I want to talk a little bit about adding fractions, and not so much how to do it, we'll go over how, but why we have to do it the way we do. So if I ask people, how do you add two fractions, very often common denominator comes up. But something to think about is, instead of just memorizing these rules, why do you need a common denominator in the first place? Really, it comes down to these are different size pieces. Notice 1/2 means you have one piece, but since it's cut into two, they're slightly bigger pieces. So the big thing in this to keep in mind is the denominator doesn't tell you how many of something you have exactly. It tells you how many it's cut up into, which translates to the size of the piece. If I cut this into more and more and more pieces, you notice they each get a little smaller. Another thing to think about is if I'm baking, I have a 1/2 and a 1/3 cup. The most notable thing about them is they're different sizes, because this is half of one whole. This is what I would get if I took one whole cut and split it up into 3 segments. Even when I'm thinking about how I store them, the 1/3 fits inside the 1/2, so it's a smaller piece. And we can see that here in the green and pink. So to be able to add them together, I need to be talking about the same thing. It's like I have apples and oranges. If I can give them the same name somehow, then I can talk about how many I have. And even notice here at the bottom, I put 1/2 and 1/3 together, so there's 1/2 plus 1/3. But I don't have a name for that. It's kind of looks like it's almost one, it's one missing a little chunk. I don't know, I don't have a good name for it. But if I can get them to be the same size, then I can tell you exactly how many this bottom one is. So if I get them to be the same size, well, how can I do that? Well, I probably need to cut them both up into more pieces, right? I can't do less since this is an already reduced fraction. You can see if I cut this in half, there's no way to give me the same part. But let's say, just on trying it out, let's say I take the 1/3 size pieces and I cut them all in half. So now how many pieces do I have? Well, there's 1, 2, 3, 4, 5, 6 in the whole circle, and I have 2 of them. So I just showed that 1/3 and 2/6 are what's called equivalent fractions. They describe the exact same amount. I didn't change the amount, I just cut it up differently. So still the same amount of pizza or something, same amount of pie here, it's just cut up differently. How do I do that algebraically? When you hear that rule about you can multiply anything you want, as long as you do it to the top and bottom, here's why. Because if you're cutting up pieces in half, you're doing the ones you have and the whole thing. So if I multiply by 2 on the top and bottom of 1/3, I can see 2/6 mathematically, as well as in the picture, is an equivalent fraction. Alright, so what about 1/2? Well, this is where least common denominators comes in. And start thinking, if I was just guessing, if I cut these pieces in half, see how I'd have 4 of them? So that doesn't make it the same size. How can I make them the same size? Well, if I can think of a number that 2 and 3 both go into, like 6, then that tells me exactly how many my goal is. I want to turn this into 1/6 size pieces. Well, if I have 2 pieces and I want to have 6, it looks like I need to cut all the pieces I currently have into thirds. So that one I had is now 3, the one I didn't have is now 3, and so you can see now the whole thing is 6. And so I'm showing myself, or algebraically, if I was multiplying by 3/3, and notice 3/3 is 1, right? What's something divided by itself? So you're multiplying by 1, you're not changing the amount you have, you're just giving it a different name. So now I can see, oh, 1/2 was the same as 3/6, 1/3 was the same as 2/6, and so back over here, I now have a name for that amount I have. If I add 3/6 and 2/6, it looks like I have 1, 2, 3, 4, 5 1/6 size pieces. So you never ever add the denominators, because the denominators aren't exactly a count of what's going on, they're the size of the pieces. So we need to get the pieces to be the same size before we can add them. And I realize what happens is that maybe in this example you think that's easy, I wouldn't forget that, but thinking about the fact that we need common denominators to get the same size pieces, so you never add the denominator, when it turns into all x's and y's, it's a little bit easy to forget some of those rules. So coming back to an example like this, even a more complicated example works the same way. You need the same size pieces.